Assalamualaikum warahmatullahi wabarakatuh. This video is about solving problem for dynamic subject assignment part 2. Okay, so my name is Siti Rashikin binti Muhammad Yazid. I'm from FKP S1K2. So let's go. So this is our first question. The first question is the object from part 1 is released from the rest and slide down along the smooth frame as shown in figure 1. Given y naught is taken from value in part A. Okay, so we transfer this figure to new page. Okay, so the question state that the value for y naught is taken by in part 1. In our previous video, our y naught is 1 meter, so we use 1 meter here, and our object is a ball, which for this question it's referred to this box. So our mass for this box is 1 kg. Okay, so our mass is 1 kg. Okay, for the first question, it says that sketch the free body diagram for the object. So, first question, we draw the ramp. This is our box and our weight. This box has weight. It has N, normal force, and force. This is for FBD. Okay. For kinetic diagram, this box has acceleration ma. Okay, so that is for the first question, that sketch the free body for the box. Next question is calculate the speed of the object just before it leaves the surface at B. Okay, so the question one, the velocity at the end. So velocity at final. B is our final, A is our initial. So how to calculate the velocity is we can use the equation that given to us. Okay. This equation actually equation 1 at the front page of our assignment. This one. Okay, equation 1. So we rewrite this. So T1 and T2 is kinetic energy. For U is work done by all force acting on the particle. Okay, so kinetic energy is 1 over 2 mv squared plus mgh for work done equal to kinetic energy same and half mv squared. Since 1 for initial and our initial is start with A, so we put VA. For final, we put VB since it's at point B. Okay, so we know that our particle mass are constant. Okay, it's 1 kg. So we can cancel the M because it's constant. So it left with half VA squared plus GH 1 over 2 VB squared. Okay, we know that the particle is from rest, which means our VA will be 0. So we put 0. Okay, and G is a velocity of gravity. So 9.81. Okay, the height we refer to the figure. Okay, the particle will be go down to this point. Okay, this one is 1 meter and this one is 3.5 meter. So we need to 3.5 minus with 1, we get this height the particle travel. Okay, so 3.5 minus 1 meter, we got 2.5. Okay, so 1 over 2 VB we need to find square. So this becomes 0. Okay, this one we calculate 9.181 2.5 equal 2.24525. Okay, this one is 1/2 VB squared. Okay, we leave the VB at one side. Okay, so 24525 divided by 1/2 VB squared. So answers divide by 1/2. We got 4905 GB. Third answer, we got 70036 ms GB. So this is our velocity at B at the final. This one.
Hello and good day everyone, my name is Muhammad Hakimi bin Shahrin and I will provide the answers for question number 1, C and D. Let us look at question C. If you analyze, the question C asks us to calculate the distance from the wall of the ramp at B to where the object strikes the ground. So question C want the distance here, from here to here, when the ball strike the ground. So how do we attack this question? So let us look. If we want to solve this question, we need to use this equation: y equal to y naught plus vy naught times t plus half ac t square. Now ac, we need to replace ac with the gravitational acceleration, because this is in y component. So therefore the equation will be y equal to y naught plus vy naught times t plus half gt square. Now when we look at this figure, this is 1. So ball, from the initial distance, from the initial place of ball will be at -1 in y component. So we put the -1 here, which is y, equals to 0, y naught here 0, plus with vy naught, which is 0, and vy naught, which is 0 times t, also will get 0, plus half gt square. G we will replace with -9.81 t square. Now we can get t square. Now we can get the time taken. So the time will be 0.45155. To calculate the distance in x component, we use x equation, which is x equal to x naught plus vx naught times t. We have the t, so we just put the t in. Now vx naught, we need to use vb, which we get at question B. So vb is equal to 7.0036. So we put in the equation x equal to 0, which is x naught 0, plus with 7.0036 times with 0.45155, and therefore we will get x is equal to 3.1614 meter. So this distance is 3.1614 meter. That's it for question C. We move on to question D. Question D says to compute the speed at which the object hits the ground. So we look at this figure, this sketchy. So we want the speed when the object hits the ground. So we want the speed here. So to get speed here, we use the principle of work and energy, which is from equation 1 here. So principle of work energy is T1 plus total U at 1, 2 equals to T2. T1 is kinetic energy. So kinetic energy is half mv square plus total work done. Total work done here is potential energy. So we use mgh equal to also kinetic energy, half mv square. So this is initial and this is final. So V initial, we take V initial is equal to VB here. So we just put the value. So half m, because m is constant, so we can ignore the m. So the equation will be VB, because V initial is VB square plus gravity and times with height equals to half VF V final. So we want this V. So we just input the value. VB is 7.0036 square plus G, the magnitude of G is 9.81 times with height, which is 1. So height, because this Y is 1, so from here to here 1 equals to half V final square. Therefore we can calculate the V final. So we get V final is 8.2868. The unit is meter per second. This is the final velocity of the ball when it reaches the ground. V final, which is 8.2868 meter per second. So that's all for me.
Hi, Assalamualaikum. My name is Muhammad Daniel. I want to proceed for the question 2, which is the object from part 1 released from rest and slides down along a smooth ramp as shown in figure 2. So note, assume y naught equal to 1 meter if y naught equal to 0 in part 1. So in this diagram, this is a figure 2 actually. So y naught equal to 1 meter, y naught equal to 1 meter. So we can use this graph, the 0, okay, the 0. So question A, calculate the velocity of the object just after it rebound from the ground. So actually we in this question we can use this equation 3 as given at the introduction, which is E, coefficient of restitution, equal to VB2 minus VA2 divided by VB1 minus VA1. Okay. So this question, E equal to VB2 minus VA2 divided by VB1 minus VA1. So VB2 we can replace with VG2 minus VVA. We can replace VCY 2 divided by VCY1 minus VG1. So since the coefficient has been given on the question here, E equal to 0.7, so we can substitute the E to 0.7 equal to Vg is 0 minus Vcy2 divided by Vcy1 minus Vg 0. So actually we can calculate the VCY1. So how we can use this equation. VCY1 squared equal to V1Y squared plus 2AC divided by AC divided by SY naught. Okay, we can refer this figure to. So since the graph here, so V1 actually at the long x-axis, this one x-axis, this y-axis. Since V1 on the x-axis graph, so Vy is 0. So that's why it is 0 squared plus 2g, we replace AC with g, gravity, divided by AC here, this AC, this C, okay, B, C. So here -1, AC -1 minus 0, this up here 0, SY naught here. So we calculate 0 plus 2, gravity -9.81 divided by -1. So here actually we get VCY1 because they have a power of 2. We pindah, we need to square root the answer. So square root 19.62. So the answer is 4.4294. Since we know the ball toward the downward, so we need to put down here. We also known as -4.4294. Here, this answer with the magnitude. This magnitude. Okay. We also know here the ball after bounce here, and yep, let's see the ball going downward. That's why we will put negative. After that, we substitute back with the coefficient formula, which is 0.7 equal to 0 minus VC2 divided by VC1 minus 0. So equal to 0 minus VCY2, VCY1, we get -4.4294 minus 0. So we can calculate, and we get VCY equal to 3.1006 meter per second. So this one to calculate VCX, M, we can use this formula M divided by VBX equal to M VCX. Since the mass is the same, we can cancel out. VBX actually we got from the question 1. VBX we got from the question 1, 7.00636 equal to VCX. Okay, so this vector equation, 7.0036I plus 3.1006G. Okay, and we can calculate the magnitude VC2, square root 7.0036 squared plus 3.1006 squared, we get 7.6593 meter per second. This is answer for question 1. Okay. For question B, The question compute the maximum height to which the object rise after the first bounce. So here they mention here after the first bounce, the object go upward and go back downward. So the for B, we need to calculate this h maximum height for the object. So here for this question we can use this formula, same for the question B, v2y squared equal to vcy equal plus 2g divided by s2y minus scy. We already know the v2y is 0 because vy doesn't exist. For this question equal to vcy, we already calculate at the question A, 3.1006 squared plus 2 negative 9.81 s2y is the height from this height. So this, okay, this 0, this scy s2y, this scy, so this 0 and the height is s2y. Okay, so if we substitute with h, minus 0 because this at the origin. Okay, so we calculate this one, we get 19.62h equal to 9.6137 and divide here, this divide here, we get h equal to 0.49 meter. So the height this is 0.949 meter. That's all for question 2.